All right, so let's talk about carbon capture. It's a huge piece of the energy puzzle, right? But it comes with a massive challenge. We're talking about injecting CO2 deep underground at some seriously high pressures. So the big question is, how do we make absolutely sure it stays there safely? That's exactly what we're going to dive into today. You've probably heard this phrase a million times. Safety is paramount. But here, it's not just some slogan you see on a wall. When you're dealing with CO2 under that kind of pressure, it is literally the bedrock of the whole operation. There's just no room for mistakes. Okay, but what does paramount even mean in practice, day to day? How do you actually take that big idea and turn it into real-world actions that keep people and the environment safe from the pretty unique dangers that CO2 brings to the table? To build the right defenses, you gotta know what you're up against. And with CO2, the threat really has two faces. One is this immediate, invisible danger, and the other one is slow, sneaky, and corrosive. So, on one hand, you've got the immediate danger, asphyxiation. See, CO2 is heavier than air, so if there's a leak, it doesn't just float away. It can pool in low areas, pushing out all the oxygen. It's totally invisible and incredibly dangerous. Then you've got this other, long-term threat, corrosion. When CO2 gets mixed with even a little bit of water, it creates something called carbonic acid. And that stuff can just silently eat away at pipes and equipment from the inside. A hidden, chronic problem. Okay, so you've got these two very different threats. How in the world do you build a fortress to keep everything safe? The answer isn't some magic bullet. It's all about having multiple overlapping layers of defense. It's a combination of really smart systems and really vigilant people. Let's start with the first, and maybe the most critical line of defense, the system itself. The whole goal here is to engineer safety right into the design from the very beginning. We're talking about a system built from the ground up to do one thing really well, contain and control that high-pressure CO2. So what does that look like? Well, for starters, it means using incredibly robust equipment, stuff that's specifically designed to handle insane pressures and stop failures before they can even start. Then you've got these sophisticated leak detection systems acting like a 24/7 watchdog, constantly on the lookout for any tiny drop in pressure. And to battle that slow, creeping corrosion we talked about, that's where you have super strict protocols to make sure every single pipe, every single valve stays in perfect condition. But even the smartest, most high-tech system in the world is only half the story. You absolutely need the human element. The people working on site, they are the final and most essential line of defense. It's their training, their awareness, that turns a safe system on paper into a genuinely safe operation in the real world. And a huge part of that human element is the gear they use. I'm talking about PPE, and probably the single most important piece of that is a portable CO2 detector. You can almost think of it like a sixth sense for the workers. It's this little device that screams at them if they walk into an area where that invisible gas is building up. It's the direct counterattack to that asphyxiation risk. Okay, so we have our system defenses, and we have our human defenses. But how do you make sure they're not just two separate things? How do you get them to work together seamlessly? Well, that's where a comprehensive safety management system comes in. It's like the master plan that connects all the dots. Now, this isn't just some dusty binder full of rules sitting on a shelf. It's a living, breathing framework. It lays out exactly who is responsible for what. It details every single procedure, and this is the most important part. It's all about being proactive. It's about spotting and managing risks before they turn into incidents. You could really call it the brain of the entire safety operation. And this is where it all comes together. If you look at this, you can see the whole strategy laid out pretty clearly. Every risk has a specific defense. See that asphyxiation risk? It's tackled by both the big system-level leak detectors and the personal detectors the workers carry. And what about corrosing or mechanical failure? The main lines of defense there are baked in from the very beginning with super strong equipment design. The point is, every single threat has a dedicated countermeasure. So if there's one thing to take away from all this, it's this. Modern industrial safety isn't about one single gadget or one simple rule. It's a complete, integrated system. It's really a partnership where technology provides that first line of defense and smart, highly trained people provide the final, crucial one. They absolutely have to work together. And that kind of leaves us with a big question to think about, doesn't it? As we keep pushing the boundaries with new energy technologies, we're going to face new challenges, new risks we haven't even thought of yet. The real test is going to be whether our definition of safety, this whole complex dance between technology and people, can evolve fast enough to keep up.